Alright, so first we have this function and we have to find the two turning points. Of course, the turning points occur when y dash equals 0. So we need to differentiate first. So again, it's got a u and a v, so we need u dash v plus v dash u, the product rule. So if I differentiate e to the x, I just get e to the x. So I leave that one. Then if I differentiate 1 minus x on 10 to the power of 10, so that 10 is going to come down, 1 minus x on 10 becomes to the power of 9, then I go inside the bracket, so I have to use a chain rule, and I've got a negative 1/10 that I need to negative 1/10, also times it by, and then I'm going to leave the e to the x, so that's v dash u. So we can see here, we want to factorise because we're looking for zeros. So if I put, they've both got an e to the x, and they've both got 1 minus x on 10 to the power of 9. This first term has one more of these, and the second term is the just minus, because 10 times negative 1 on 10 is negative 1, so it's just negative 1 of that. Alright, so that's nice because now it's kind of fully factorized. So I've got that, and here 1 minus 1, and then this is minus x on 10. So if I was setting that to 0, then what would, so e to the x can't be 0. We already know that. So from this bracket, you could see if x is 0, I would get everything is 0. And from this bracket, you can see if x is 10, I would get 0. So these are going to be my stationary points. So I'm going to get 0 something and 10 something. Alright, if I put 0 back in here for x, e to the 0 is 1, and then I've got 1 to the 10, which is still 1. So 0, 1. And then if I put 10 in there, I'm going to have e to the, just put it here, e to the 10, but here I'm going to have 1 minus 1, which is 0, to the 10. So I'm going to get a 0. Anyway, so they're my two stationary points. So now it says discuss the behaviour of the function as x goes to plus and minus infinity. So let's go back to the function and have a look. So our function being e to the x, so we know e to the x as x goes to infinity. X goes to infinity. Our e to the x will also go to positive infinity. And then our other part of that function is 1 minus x on 10 to the power of 10. And we know that that also, as x gets larger and larger, so we know 1 minus x on 10, it's going to get larger and larger but be negative, but it's to the power of 10, which is an even power, so negative squared, for example, is always positive. So it's going to go towards infinity, and we think it's going to be negative, but then it's, you know, to the power of an even number, so it's actually going towards positive infinity. So how do I say that? So that and 1 minus x on 10 to the 10 also goes towards infinity, positive infinity. So therefore, as x goes to positive infinity, y also goes to positive infinity. So let's have a look at what happens when x goes to negative infinity. So we'll still get, for this first part, if you think about it, I could put in like negative infinity. I've got 1 on e to the infinity. So still, it's positive, it's just getting smaller and smaller, so actually going towards 0. Actually, we also know that as x goes towards negative infinity, we know that e to the x, x to the n, you may know this or you may not, it tends to 0 for any n. So we've got that, we've got e to the x and something, some x to the power of n. So our graph, e to the x, 1 minus x on 10 to the 10, is actually going to go towards 0. Because this part, this 1 minus x to the 10, or to the power of 10, that if you expanded all of that, then it expands to the sum of the powers of n. So as x goes towards negative infinity there. So this is just going to go towards 0. So our y is going towards 0. So if we then want to graph this graph, what do we know so far? We know that we've got a turning point at 0, 1 and a stationary point, and we've also got a stationary point at 10, 0. Let's say that's 10, 10, 0. We also know that as x goes to infinity, this graph goes to infinity. So as x gets bigger and bigger and bigger, this graph gets bigger and bigger and bigger. Now we have to make it up to this point because that's a turning point. We also know when x goes to negative infinity, we get closer to 0. So we're going to go like that. And that point's at 1. So from the graph, can we deduce that e to the x is less than or equal to that? So let's put all this. It does say for x is less than 10, so we're less than 10. So we're looking at all this part here. So for all this graph, what do we know? Like, what inequality can we use? Well, we can use the fact that, because that's what we're looking for, some inequality here. We can use the fact that the whole graph, the whole y or e to the x, 1 minus x on 10 to the 10, power of 10, that's always going to be less than or equal to 1, right? The highest point is 1 so we're only looking for x is less than 10. So maybe that will give us enough if we rearrange it. We've got e to the x, and we can divide by this here, and that will get us, and I'll go through in a second, when we divide it become 1 on whatever to the power of 10, so the same as to the power of negative 10. But how can we divide that? Are we allowed to divide? So we will get the answer. So how can we divide that and keep the inequality as a less than or equal to, not changing it? Well, it has to be positive. And we know that 1 minus x on 10, where x is always less than 10, that's going to stay as positive. Also, it's to the power of 10, so it's got to be positive. Okay, so it's all okay to do that. Alright, so then it says hence, so I'm definitely going to use what we just did. So, and it's got some numbers in it, so we're just going to substitute some no x's. So we're going to let x equal, alright, so how will I get an 11? So if I just look at this part in here, that's going to be 10 minus x. So to get an 11, I'm going to have to put x equals negative 1 in there. So let's try it and see. So I know that if I put a negative 1 in, I'm going to get e to the negative 1 is less than or equal to, this will be, did I just say 11? Yes, 11 on 10 to the minus 10. Alright, so that is 1 on e is less than or equal to 11 on 10, or 10 on 11 to the power of 10. Oh, okay, so I want e to be greater than, which makes sense because if I do, they're both positive, so if I do the reciprocal, I can change this inequality to that part. Okay, taking reciprocals of positive numbers, I get that, which gives me this part of the inequality. So I also need a 10 on 9. So if I maybe make x equal 1, that gives me a 9 on 10. We'll start with that. So back into here, I've got e to the 1 is less than or equal to 1 minus, so 9 on 10. Is that right? To the minus 10. Let me rub that out because I feel like I'm a little bit lost here. Get rid of that. Alright, let's just check that I'm doing the right thing. So I'm putting x equals 1 in this time, so I get e to the power of 1, which is 1. I get 1 minus, so 10 minus 1, which is 9 on 10 to the negative 10. So if I want a positive, I'm going to, oh yeah, because I want it upside down, don't I? Oh, silly me. Alright, So if I want to express it without that negative, I'm just going to put it upside down so it's the same as that. So it's exactly the same as that, and that gives us this. Don't confuse yourself like I do. So putting those two inequalities together, we do get that last inequality.